New Jersey electrical exam may include load calculation questions. These questions could address any element of a complete load calculation. This means you should be ready to tackle questions concerning lighting, receptacle circuits, cooking appliances, heating, ventilation, and air conditioning, also known as HVAC systems, and other electrical loads. The questions can be structured in different ways. You might encounter individual questions that focus on a specific part of the load calculation process. Alternatively, you could face more extensive scenario-based questions that require you to perform a more comprehensive load calculation. To successfully pass the exam, it is crucial to have a thorough understanding of all aspects of load calculations. This includes understanding the relevant articles in the National Electrical Code, or NEC, which provides the rules and guidelines for safe electrical installations. Let's break down the key areas you need to master. Firstly, general lighting loads. These are determined based on the occupancy and square footage of the building. The NEC provides tables, such as Table 220.12, which lists the general lighting loads for various occupancies in volt-amps per square foot. To calculate the total general lighting load, multiply the square footage of the building by the volt-amps per square foot value from the table. Secondly, receptacle loads. For general use receptacles in non-dwelling occupancies, the NEC requires an allowance of 180 volt-amps per outlet. In dwelling units, the general lighting and receptacle loads are combined and calculated based on the square footage. For specific appliances and equipment, the actual nameplate rating is used to determine the load. Thirdly, appliance loads. For appliances like ranges, ovens, dryers, and water heaters, you need to use the nameplate rating of the appliance. The NEC provides demand factors that can be applied to these loads, especially in dwelling units, to account for the fact that not all appliances will be operating at the maximum load simultaneously. For example, Table 220.55 provides demand factors for household ranges and ovens. Fourthly, motor loads. Motor loads are calculated based on the horsepower rating of the motor. The NEC provides tables, such as Tables 430.248 and 430.250 that list the full load current for motors of various horsepower ratings and voltages. The full load current is used to determine the conductor ampacity and overcurrent protection for the motor circuit. For motors that operate intermittently or have varying loads, demand factors may be applied. Fifthly, HVAC loads. Heating, ventilation, and air conditioning loads can be significant, especially in commercial buildings. These loads include the power required for the heating and cooling equipment, as well as the ventilation fans. The load calculation should include the nameplate rating of the equipment and any applicable demand factors. For air conditioning equipment, the NEC requires the use of the largest of either the cooling load or the heating load. Sixthly, feeder and service calculations. Once you have calculated the individual loads, you need to combine them to determine the total load on the feeders and service. The NEC provides rules for applying demand factors to these loads, which can reduce the overall size of the conductors and overcurrent protection required. Demand factors are based on the diversity of the loads and the likelihood that they will all be operating at the maximum load simultaneously. Seventhly, optional method. For dwelling units, the NEC allows an optional calculation method that simplifies the load calculation process. This method is based on the total square footage of the dwelling unit and includes allowances for heating, air conditioning, and appliances. The optional method can be used when the total load calculated using the standard method exceeds the capacity of the service. Eighthly, voltage drop. Voltage drop is the decrease in voltage that occurs along a conductor due to the impedance of the conductor and the current flowing through it. The NEC recommends limiting voltage drop to 3% for feeders and 5% for branch circuits. Excessive voltage drop can cause equipment to operate inefficiently or not at all. The voltage drop can be calculated using Ohm's law, which states that voltage drop is equal to the current multiplied by the impedance of the conductor. Ninthly, conductor sizing. Conductor sizing is the process of selecting the appropriate size of conductor to carry the calculated load. The NEC provides tables, such as Table 310.16, that list the ampacity of conductors of various sizes and insulation types. The ampacity of the conductor must be equal to or greater than the calculated load. Conductors must also be protected against overcurrent by an overcurrent device, such as a circuit breaker or fuse. 10th, overcurrent protection. Overcurrent protection is the use of circuit breakers or fuses to protect conductors and equipment from overloads and short circuits. The NEC specifies the maximum allowable overcurrent protection for various types of conductors and equipment. The overcurrent protection device must be sized to protect the conductor from overheating and to prevent damage to equipment. The overcurrent protection device should also be coordinated with the conductor size to ensure that the conductor is protected under all conditions. 11th, grounding and bonding. Grounding and bonding are essential for electrical safety. Grounding is the connection of electrical equipment to the earth, which provides a path for fault current to flow back to the source. Bonding is the connection of metallic parts of the electrical system together, which ensures that they are all at the same potential. Grounding and bonding help to prevent electric shock and fire hazards. 12th, special occupancies. The NEC has specific requirements for special occupancies, such as healthcare facilities, hazardous locations, and swimming pools. These occupancies have unique electrical hazards that require special attention. The load calculation for these occupancies must take into account the specific requirements of the NEC. 13th, emergency systems. Emergency systems are designed to provide power to essential loads during a power outage. These systems typically include emergency lighting, fire pumps, and life safety equipment. The load calculation for emergency systems must take into account the specific requirements of the NEC. The NEC requires that emergency systems be tested regularly to ensure that they are functioning properly. 14th, calculations for services. Service calculations involve determining the total load that the electrical service must be able to supply. This includes the general lighting and receptacle loads, appliance loads, motor loads, HVAC loads, and any other loads that will be connected to the service. The service must be sized to handle the total load with consideration given to demand factors. The NEC provides guidelines for calculating service loads for various types of occupancies. 15th, understanding demand factors. Demand factors are multipliers applied to connected loads to estimate the actual load that will be drawn at any given time. These factors are based on the idea that not all electrical equipment will be operating at its maximum load simultaneously. Demand factors vary depending on the type of occupancy and the types of loads involved. Using appropriate demand factors can reduce the required size of the service and feeders, leading to cost savings. 16th, applying the NEC. The National Electrical Code is a comprehensive set of standards and guidelines for safe electrical installations. It covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. The NEC is updated every 3 years, so it is important to stay current with the latest edition. Familiarity with the NEC is essential for anyone working in the electrical industry. 17th, plan review. Before beginning any electrical installation, it is important to have the plans reviewed by a qualified electrical inspector. The inspector will review the plans to ensure that they comply with the NEC and local codes. The plan review process can help to identify potential problems before they become costly and time-consuming to fix. 18th, the inspection process. After the electrical installation is complete, it must be inspected by a qualified electrical inspector. The inspector will verify that the installation meets the requirements of the NEC and local codes. The inspection process is designed to ensure that the electrical installation is safe and reliable. 19th, documentation. It is important to keep accurate records of all electrical work that is performed. This includes the plans, specifications, calculations, and inspection reports. This documentation can be useful for future maintenance and troubleshooting. Proper documentation can also help to demonstrate compliance with the NEC and local codes. 20th, safety practices. Electrical work can be dangerous if not performed properly. It is important to follow safe work practices at all times. This includes wearing appropriate personal protective equipment, such as gloves and safety glasses. It also includes de-energizing circuits before working on them and using lockout/tag-up procedures to prevent accidental energization. 21stly, using the right tools. Using the right tools for the job is essential for both safety and efficiency. Make sure to have the necessary tools for performing load calculations, such as a calculator, a measuring tape, and a copy of the NEC. Use high-quality tools that are in good condition. 22ndly, practicing calculations. The best way to prepare for load calculation questions on the electrical exam is to practice performing calculations. Work through examples from the NEC and other sources. This will help you to become familiar with the different types of calculations and the relevant code requirements. 23rdly, understanding tables. The NEC contains numerous tables that are used in load calculations. These tables provide information on conductor ampacity, overcurrent protection, demand factors, and other important parameters. Take the time to understand these tables and how to use them. 24thly, seeking clarification. If you are unsure about any aspect of load calculations, don't hesitate to seek clarification from a qualified electrical instructor or engineer. It is better to ask questions and get the correct answers than to make mistakes that could lead to unsafe electrical installations. 25thly, time management. Time management is crucial during the electrical exam. Allocate your time wisely and don't spend too much time on any one question. If you are struggling with a question, move on to the next one and come back to it later if you have time. 26thly, staying calm. It is important to stay calm and focused during the electrical exam. Don't let anxiety get the best of you. Take deep breaths and try to relax. If you are well prepared and confident in your abilities, you will be more likely to succeed. 27thly, reviewing your work. Before submitting your exam, take the time to review your work. Check your calculations and make sure that you have answered all the questions correctly. Even small mistakes can cost you points, so it is important to be thorough. 28thly, understanding different occupancies. Load calculations vary depending on the type of occupancy, such as residential, commercial, or industrial. The NEC provides specific requirements for each type of occupancy. Make sure you understand these requirements and how they affect the load calculation process. 29thly, single-family dwellings. For single-family dwellings, the load calculation process involves determining the general lighting and receptacle load, the appliance load, and the HVAC load. The NEC provides specific rules for calculating these loads. 30thly, multi-family dwellings. For multi-family dwellings, the load calculation process is more complex. It involves determining the load for each individual dwelling unit, as well as the load for common areas such as hallways and laundry rooms. The NEC provides specific rules for calculating these loads. 31stly, commercial buildings. For commercial buildings, a load calculation process involves determining the general lighting and receptacle load, the appliance load, the motor load, the HVAC load, and any other loads that will be connected to the service. The NEC provides specific rules for calculating these loads. 32ndly, industrial buildings. For industrial buildings, the load calculation process is the most complex. It involves determining the load for a wide variety of equipment and processes. The NEC provides specific rules for calculating these loads. 33rdly, healthcare facilities. Healthcare facilities have unique electrical requirements due to the critical nature of the services they provide. The load calculation for healthcare facilities must take into account the specific requirements of the NEC. 34thly, hazardous locations. Hazardous locations are areas where flammable gases, vapors, or dust may be present. Electrical equipment in hazardous locations must be designed to prevent ignition of these materials. The load calculation for hazardous locations must take into account the specific requirements of the NEC. 35thly, swimming pools. Swimming pools have unique electrical hazards due to the presence of water. The load calculation for swimming pools must take into account the specific requirements of the NEC. 36. Agricultural buildings. Agricultural buildings have unique electrical requirements due to the presence of livestock and other agricultural activities. The load calculation for agricultural buildings must take into account the specific requirements of the NEC. 37. Marinas and boatyards. Marinas and boatyards have unique electrical hazards due to the presence of water in boats. The load calculation for marinas and boatyards must take into account the specific requirements of the NEC. 38. Temporary installations. Temporary electrical installations are often used for construction sites and other temporary events. The load calculation for temporary installations must take into account the specific requirements of the NEC. 39. Mobile homes and recreational vehicles. Mobile homes and recreational vehicles have unique electrical requirements due to their compact size and mobile nature. The load calculation for mobile homes and recreational vehicles must take into account the specific requirements of the NEC. 40. Renewable energy systems. Renewable energy systems such as solar photovoltaic systems and wind turbines are becoming increasingly common. The load calculation for renewable energy systems must take into account the specific requirements of the NEC. 41. Energy storage systems. Energy storage systems such as batteries are being used to store energy from renewable sources and to provide backup power. The load calculation for energy storage systems must take into account the specific requirements of the NEC. 42. Electric vehicle charging equipment. Electric vehicle charging equipment is becoming increasingly common as electric vehicles become more popular. The load calculation for electric vehicle charging equipment must take into account the specific requirements of the NEC. 43. Data processing equipment. Data processing equipment, such as computers and servers, requires a reliable and stable power supply. The load calculation for data processing equipment must take into account the specific requirements of the NEC. 44. Elevators and escalators. Elevators and escalators require a significant amount of power to operate. The load calculation for elevators and escalators must take into account the specific requirements of the NEC. 45. Fire pumps. Fire pumps are essential for providing water to fire suppression systems. The load calculation for fire pumps must take into account the specific requirements of the NEC. 46. Welders. Welders can draw a significant amount of power. The load calculation for welders must take into account the specific requirements of the NEC. 47. X-ray equipment. X-ray equipment requires a high voltage power supply. The load calculation for X-ray equipment must take into account the specific requirements of the NEC. 48. Inductive heating equipment. Inductive heating equipment uses electromagnetic induction to heat materials. The load calculation for inductive heating equipment must take into account the specific requirements of the NEC. 49. Dielectric heating equipment. Dielectric heating equipment uses radio frequency energy to heat materials. The load calculation for dielectric heating equipment must take into account the specific requirements of the NEC. 50. Electrolytic cells. Electrolytic cells are used to produce metals and other chemicals. The load calculation for electrolytic cells must take into account the specific requirements of the NEC. By understanding the content in the National Electrical Code, you will have a solid foundation for tackling any load calculation question on the New Jersey electrical exam. Remember to study diligently, practice calculations, and stay up to date with the latest code requirements.